All right, this is the 2013 telescopic 2D array program, number 4 that they do. So let's read this. A telescope scans a rectangular area of the night sky and collects the data into a one-dimensional array. Each dark value scanned is a number representing the amount of light detected by the telescope. The telescope scans back and forth across the sky, alternating between left to right and right to left in the pattern indicated below by the arrows. So back and forth, it's going here, boom, 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 boom. So the telescope records the data in telescope order so it's putting it into a one-dimensional array of double values. This one-dimensional array of information received from a single scan will be transferred, so they're going to put it into a two-dimensional array, which reconstructs the original view of the rectangular area of the sky. This two-dimensional array is part of the sky view class. So this is kind of hard to see, but here's your 2D array. It's called view right here. Okay. Then it's got a sky view constructor that gets passed in the num rows, number columns, and the scanned one-dimensional array. And then there's a get average where you get the start row, start column, and end column. So let's look at this. So scan, this is what's passed in. Okay. There's 12 array elements in here. So it'll be put in with 4 rows and 3 columns, starting off at 0, 1, 2, 3, and 0, 1, 2. So these are your rows running down, your columns run across. So in this 4, 3, and scanned would be passed in. And you're basically building your view 2D array to look like this right here. Now notice it goes 0.3, 0.7, 0.8, and then 0.4 is right here. So it's kind of in like the picture up above. It's putting it in serpentine order. Okay, so kind of like a snake. That's called serpentine order. So one thing you need to notice about serpentine order right here, it's left to right and then right to left. So this row is an even row. 0 and 2 are even rows. 1 and 3 are odd rows. So one thing that we'll have to think about is when you're doing your for loop, with this one you'll start with 0 and go to the end, and in this one you'll start at the end and go and count down. So I'll show you that in a minute. Let's see, for another purpose, so there's another example you can look at. Alright, so what I did is I set up the sky view, and so we want to be able to set up view. So view is a new double, and the number of rows and columns it has is what was passed in. So num rows and num columns. So these are both just passed in. Okay, so now view is set up properly, and so we'll do this. We'll say for int row. Actually, let me think about this real quick. I'm gonna do one more thing because we're gonna need. We need count. We need a count. Yeah, we need an I here. We need a counter. I'll explain that in a second. Int I equals 0. All right, so we're always going to go from 0 to the end here, okay? Now the only difference is between each one. So normally what we would do is we would have for int call. Call would be less than num columns call plus plus. Okay, normally we would do just this, but this will only work when we're in an even row. So right here we'll say if row modulus 2 is equal to 0, okay, then we'll run this one. Else we will run this one. All right, so again, if we're in an even row, okay, so remember 0 and 2 are even rows, we're going to go from left to right. But if we're in an odd row, we need to go from the last column in it, -1, so where they say that they passed in 3 columns, so 3 minus 1 is 2, so it'd start at 2 and then go 1, 0. Okay, and what we're going to be doing is plugging this information in from the one-dimensional array. So the reason why I set up an I here is because we have to be able to count through each element of the scan one-dimensional array. So right here we'll say view, and we're in row column, okay, and that's going to equal the scanned I, and once we store that position in there, whatever position they're in, 0, we do I plus plus, okay, and now I becomes 1, and we can run through each one, okay, and it's going to be the same thing, whoops, it's going to be the same thing down here, so I can just copy and paste. And that should properly populate our 2D array view with the one-dimensional array in serpentine order. Okay. Now the next one, let's see here, what's the next one doing? The number of rows represent the view. Okay, rows, columns. The view has been created as a rectangular two-dimensional array with num rows, num columns. The values have been copied in. Okay, so write the view method get average, which returns the average of the elements of the section of view with a start row, end row. So you start at 0, end at 1, and a start column 0, end column 0. So this is easy too. And so then we count them all up and figure out their average. Yeah, that's pretty easy. All right, so no problem here. So where do we begin? So in order to get a average. We need the sum of all the numbers, so we'll just say double sum equals 0.0, and we need to count them up, so we'll say int count equals 0, and then we can say for, what are we going to do, int row, and we have a start row right here, so that'll be our start row. And it doesn't necessarily have to start at 0. I mean, this could be right here where the start row would be, I don't know, 1 and 2, and start column would be 1 and 2. It just kind of depends. The row is at 1 and 2. It's not at 0 here, so that shouldn't throw you off. The row must be less than or equal to the end row. Row plus plus. And then for int call equals same thing, start call, and call is less than or equal to end call, call plus plus. And now we need to just add these all up, so it equals view and then row call and then count plus plus. Okay, so then once we have that, notice how this is a double, so can't we just should just be able to return the sum of it all divided by the count. And that's that. That should work properly. No problem. So try plugging that in, and that's it.